Welcome to the lesson on customizing build runner shape in OCI DevOps projects build pipeline configuration. I am Mahendra Mehra, your senior OCI instructor with Oracle University. Throughout this lesson, we'll explore this new feature, its significance, and navigate through the OCI console for enhanced comprehension. Let's get started. Let's explore the new feature introduced in the OCI DevOps project service, which now allows for customizing the build runner shape used for running build instructions. This enhancement provides flexibility in building and testing software with the fast and scalable Oracle Cloud Infrastructure DevOps service. You have the option to customize the build runner shape according to your project's requirements or set it to the default value. A shape serves as a template that dictates the number of CPUs, amount of memory, and other resources allocated to a newly created instance. It's important to note that you'll incur charges for utilizing the compute shape, OCPU, and memory during the build run. By default, the build runner shape comprises 2 OCPU and 8 GB memory, offering a quick start option with minimal provisioning delay. However, if you choose to customize the build runner shape, the provisioning process may take longer compared to using the default shape. These customization options empower you to optimize resource allocation and streamline your development workflow with OCI DevOps project service. Now let's switch to OCI console to see this feature in action. We'll walk through the steps to customize the build runner shape. I've switched over to the OCI console and this is my OCI dashboard. Now I'll navigate to our OCI DevOps project. I'll go to the hamburger menu, click on Developer Service, and under DevOps section I'll click on Projects. Now there's only one project within my CTD OKE compartment. I'll click open this project. I'll select the Build Pipelines option under the DevOps Project Resources section. I'll click on Create Build Pipeline to create a test pipeline to showcase the build runner shape customization option. I'll quickly give it a name, say test build. Description is optional, so I'll skip it for now and click on Create. Now to add a stage to the build pipeline, I'll simply click on the plus icon and click on Add Stage. For the stage type, I'll choose the Manage Build option and click on Next. Here, I'll enter a name and description for the stage. Now the crucial step, which is selecting the build runner shape. You have two options. You can either go with the default shape, which offers AMD Intel x86 architecture with 8 GB memory and 2 OCPU. This is the quick start option. Alternatively, you can customize the shape by selecting the custom shape option. Here you can select the required number of OCPUs and the amount of memory allocated to a flexible shape. You can use the slider to increase the number of OCPUs and the number of memory you want for your build runner shape. Do note that the customization will take longer to provision as compared to the quick start option, but by choosing the right build runner shape, you can ensure optimal performance and resource allocation for your build processes. Let's say I select 4 OCPUs and 12 GB of memory for my customized build runner shape. The rest of the configuration options remains similar to the one we saw during earlier demos for build pipelines. I'll quickly select the primary code repository. Click on Select and click on Add. And that's it. With just a few clicks, you can customize the build runner shape in your OCI DevOps project, tailoring to your specific requirements. With this, we come to the end of this demo where we saw how to customize the build runner shape used for running build instructions. These customization options will empower you to optimize resource allocation and streamline your development workflow with OCI DevOps project. I hope you found this demo useful. See you in the next one. Thank you for watching. Hello, I am Mahendra Mehra, and as part of this demo, we'll be looking at how to get artifacts from your build pipeline. This demo is divided into following tasks. The first task would be to learn how to pass parameters into the build pipeline. We will also see how to set up the output artifacts. Once we are done with passing parameters into the build pipeline and setting up the output artifacts, we will be running our updated build pipeline to examine the resulting artifacts and to see if those artifacts were created in the container as well as artifact registry. So let's get started. Okay, so before we begin, the prerequisite to this demo is that you must have already created a container registry as well as an artifact registry within the compartment where you are managing your DevOps resources. Now we will define some parameters for the build pipeline, and these are automatically made available to the build stages. They can also be used to name the outputs of the build process. To start defining parameters, let's go to our DevOps project. By clicking on this hamburger menu, going to the developer services, let me take you to the DevOps project. This is the DevOps project that we are working on. Let me click on it. And right, as you can see, currently it has been updated that we have a latest build pipeline which we did in the previous demo, as well as one latest build history of the build pipeline that we ran in the previous demo. Alright, so now the next thing that we have to do is to add parameters. To do so, you can go to your build pipelines by going to the latest build pipelines and clicking on your build pipeline. Now we are on our build pipeline UI. Click on the parameters tab. In the name field, give your parameter a name. In our case, it will be your underscore initials. So let me quickly add that. And also add the default value, which is in my case, and give it a suitable description. Okay, so I have entered the required values. So the name is your underscore initials. The default value for my initials is and the description is your initials. So why the name your initials? If you remember from the build underscore spec.yaml file, this is the location where my container image will be stored, and this is the naming convention. So I had added a placeholder your underscore initials so that I can easily identify the image that I am creating, as well as to demonstrate the purpose of passing parameters. Now to add this parameter, you need to click this plus button over here, and it will save the details for you. Remember, you have to click the plus button in order to save your parameters. So clicking on the plus is very important. Also make a note, there is no mechanism to specify parameters for each stage, so we need to do it on the entire build pipeline. Now that I have saved my parameter, I am getting option to add another. So if you wish to add another parameter, you can always go on to add another based on your requirements. Like I said, as part of the prerequisite to this demo, we need to create a container as well as an artifact registry. Let me quickly show you that these are created by us in the previous demos. So in the previous demo, we already created an artifact registry named DevOps, and similarly we had a container registry that was created called DevOps/storefront. Now that we have the places to store the artifacts, we need to extract them from the build pipeline. The artifacts are currently hanging around as the output artifact stage of the build process saved them somewhere in the build pipeline, but that's not permanent. They are just held for other pipeline stages to import if needed. To make use of them in the deployment, we need to upload them to the permanent location. In this case, the OCIR, which is our container registry, and the artifact registries were created, and that's where we're going to upload them. The output artifact stage is where we do the tagging, and so on. Here we will be using the build pipeline variables, for example storefront underscore version, as well as the pipeline parameter that we just created, your underscore initials, as part of the naming when artifacts are uploaded. There is no need to use both, but I wanted to show you how to use just in case you want to do it at some point. Click on the build pipeline to go to the designer pipeline tab. On the bottom of the build storefront stage which we created earlier, there is a plus button. We need to click this button to add a new stage. Let's click this button to add a new stage. This build stage that we are creating will run after the build storefront stage that runs ahead of it. This time from the list of stages, we will be choosing the deliver artifact stage and click next. We will give it a name and a description. Okay, so I've given this stage a name upload storefront artifacts and given it a valid description. Now we need to specify the artifacts which we need to extract and store in either in the container registry or in the artifact registry. First, we are going to deal with the YAML files, the Kubernetes manifest files which are present as part of the output artifacts. Okay, so you can have a question that why are we not using these YAML files from the code repositories directly, and why are we pushing them into an artifact registry and then using them, right? So there are two reasons why are we doing this. Firstly, we need the deployments to be reproducible and auditable. So we need to know exactly what was deployed. That means it needs to be held somewhere where it can't be changed. So in that case, we are using the artifact registry where we can make our artifacts immutable. Secondly, the important thing to note is the deployment pipelines only use artifact repositories and they don't know about the Git repositories. So we will have to have them copied from the code repository into the artifact registry. Alright, so now we will define the artifacts. Remember that here we are just defining a template specifying where the build output must be stored. This is not accessing an already uploaded artifact in the registry. The output artifact stage will use this template to upload the artifacts, making it real, and then the deployment stage can use these artifacts. So as you saw in the previous demo, we had no deliver artifact stage. All the artifacts that were generated are simply hanging around somewhere managed by the build pipeline stage, but they are not real. So to make them real, we'll have to use this deliver artifact stage, which will get them copied into the required repositories. Now click on the create artifact button to open the add artifact pop-up and provide the required details. So as we are doing the YAML files first, let's set up the details for YAML files. Let me fill all the required values. So the artifact name that I've given is storefront service YAML. So this is a service YAML file for our Kubernetes. So since it's a Kubernetes file, so let's select the type as Kubernetes. But you have other options to choose from like container image repository, instance group deployment configuration file, some general artifact, or Kubernetes manifest. We will stick to the Kubernetes manifest. Once you select Kubernetes manifest, it will ask you to provide the artifact registry details. Click on the select button to open the registry selector. Make sure the region and the compartment values are accurate. And as you can see, there is only one artifact registry that I had configured in my ctdoc compartment. It gets listed over here. So just select that particular artifact registry and click on select. Now from the artifact location, we'll use the custom artifact location and version option, where we need to specify the artifact path as well as its version. So in the set artifact location, we need to provide the artifact name, and we also need to provide the version that we want to associate to the artifact. Let me quickly populate this data. Alright, so I have populated the artifact name as service storefront.yaml, and I have given it a version which is basically a parameter, that is storefront_version. If you remember, this parameter is an exported parameter that I am using from the build process, and in the build process we extract it from the source code. This means that we know we are matching the image and the YAML versions with that of the code version. Make sure that the replace parameter is set to yes, substitute the placeholder. This will mean that the variable we have specified over here will be replaced during the artifact creation phase with their values. Currently, the status resource.java file specifies the version as 1.0.0. Click on the add button to add the artifact. So as you can see from the output, one of the artifacts has been added, and these will be delivered to the artifact registry once the build stage runs. And now similarly, we will have to add other Kubernetes manifest file, for example our ingress rule YAML file as well as the storefront deployment YAML file. I will pause the video here and quickly add those two as well. Okay, so after adding the other two YAML files, it's time now to add the template for the container image. I've already selected the create artifact button and I will be adding the details for the container image. I've given it the name storefront container, also selected the type as container image repository. So the next thing that we need to specify is the artifact source that is the fully qualified path to the image in the container registry. As you can see, we have already created the container registry. We need to provide a fully qualified path to this registry. Let me quickly add it over here. Okay, so I've added the fully qualified path, and as you can see, the path consists of placeholders which will get their values from the parameters either from the build spec file or through the parameters that we define in the build pipeline. Make sure that the replace parameter used in this artifact field is selected to yes, substitute placeholders, and click on add. Alright, so we have declared 4 artifacts. 3 of them are YAML files and one of it is the container image. Now we have defined where the artifacts are going, but we haven't connected the output artifacts held in the build pipeline to the ultimate destinations yet. In the stage section, scroll down to the associate artifacts with the build result section. You can see that the artifacts are listed in this section over here. And now we need to specify the names in the build output for each artifact. So in the build config result artifact name field, we need to enter the output artifact names. So if I take you to the buildspec.yaml file and show you the output artifacts, as you can see, each output artifact has a name associated to it. This is the name that we have to define within these fields. So let me quickly add these names in these required fields. Okay, so I've added the names from the output artifacts in the build config/result artifact name fields. Once done, click the add button at the bottom of the add stage form to add it to the pipeline. Alright, as you can see, a new stage has been added to our build pipeline. The first stage is the build storefront, and the second stage that will run after it is the upload storefront artifacts. Okay, then now that we have updated the build pipeline to upload the storefront artifacts into the required container or artifact registry, we can click on the start manual run to rerun this build pipeline. Once you click on the start manual run, it gives the build a name and tells you that the parameters you are passing into that build pipeline. As you can see, the parameters that I had passed was for your initials. Just in case you had provided wrong parameters, you can still change them at this point in time. But I'll keep it as it is, as these are correct values, and click on start manual run at the bottom. Now this build pipeline will take some time to execute. First the build storefront stage will execute, and then the upload storefront artifact stage will execute in sequence. And as you can see, the build storefront stage is in progress. The block is highlighted as amber, and the block representing the upload storefront artifact stage is currently gray as it is not selected. Alright, so all the steps within the build storefront stage are getting executed, and as and when they get executed, you get a green check mark in front of those steps. Alright, I'll pause the video here as this might take some time and resume when we reach the upload storefront artifact stage. Okay, so the first stage is running in its last step. Once this completes, the upload storefront artifact stage will start executing. Superb, the save output artifact stage from the build storefront has completed, and now the upload storefront artifact stage is executing. And as you can see on the left hand side, the border of the build storefront has been marked as green as it executed successfully, and the border for the currently executing stage is highlighted as amber. Alright, as you can see, the upload storefront artifact stage has completed with a green check, and also from the blocks over here, as you can see, both the blocks have turned green. It means that the artifacts from the previous stage has been successfully stored into the artifact and the container registry respectively. So now if I take you to the artifact registry and the container registry, within the artifact registry we must be able to see 3 YAML files for our Kubernetes, and in the container registry we must be able to see one container image, and the version of the container image must be 1.0.0 as defined in the source code files. So let's quickly jump to another tab and let me take you to the developer services. So let's first check the artifact registry. So in the current compartment CityDoc we have one artifact registry, and if I click on that, as you can see, the artifacts have been generated. So these are the artifacts that were pushed into the artifact registry once the build pipeline completed. And as you can see, the version of each artifact is 1.0.0. Similarly, let me take you to container registry. And this is the registry that we had created. So if I click on it, as you can see, there is one image that is created, and that has been versioned as 1.0.0. So let me quickly brief you what exactly happened. The first stage ran the build, and the build generated few artifacts. Those artifacts were then later stored into the container registry and the artifact registry. The container registry stores the Docker image that was generated, and the artifact registries are storing the YAML manifest files for the Kubernetes environment. With this, we come to the end of this demo. I hope you enjoyed the demo. See you in the next demo. Thanks for watching. Hello and welcome to this lesson on deployment pipelines. In this lesson, I will cover continuous delivery and deployment options, workflow, and deployment patterns. So let's get started. A deployment pipeline holds the requirements that must be satisfied to deliver a set of artifacts to the target environment. It's an integral part of the continuous deployment process within a DevOps project, which can be controlled by defining stages that run in serial or parallel. And it's usually triggered by a build pipeline but can also be run independently. I believe you still remember from the previous lesson that the build pipeline had a stage which offered us an option to trigger deployment pipeline. The last point is talking exactly about it. Before we move ahead, let us understand when and when not to implement continuous deployment within your project. You must go for continuous deployment when you want to release features faster, when deployment is a continuous routine in your business setup. Also, when you want to discover issues before the release hits production. And you must go for continuous deployment when you have all the resources needed to automate your development lifecycle with less manual intervention. You must not go for continuous deployment when it is a one-time deployment that you're planning, or when the test automation is not mature enough to confidently push your artifacts to the production in an automated environment. Again, when your business case doesn't allow you to publish to production without going through any kind of user acceptance test. Also, if your project is a high risk, high profile project, then you must avoid using continuous deployment. At this point in the course, we are already well aware about the DevOps CI/CD practices, but usually some people have a hard time understanding the difference between continuous deployment and continuous delivery. Let's address that first. The continuous delivery process typically includes at least one manual step of approving and initiating a deploy to production. In complex projects with multiple dependencies, the continuous delivery pipeline may include additional steps which are either manual or automatic. On the other hand, continuous deployment is a step further by releasing every change that passes through the production pipeline directly to your clients without any human intervention. If an automated test fails, then the change will not be sent. But if everything checks out in the testing, the changes are deployed automatically. Let's talk about some advantages of using deployment pipelines. To start your deployment, you can either automatically run a deployment from your existing continuous integration platform using triggers, or you can run your deployment on demand. The deployment pipelines also offers you advantages in terms of deploying to different environments in multiple regions. You can use either a parallel or a serial approach to do so. In your deployment pipeline, you can fully automate your deployment to include testing and delivery to each of your environment, such as developer, testing, staging, and production, and automatically promote the release all the way up to production. You can also set up deployments that include manual approval stages for automation with manual checks. Let's take a look at the deployment pipeline workflow. In this diagram, you can see how a sample application is deployed using OCI DevOps. The application is already built, stored in a repo, and is ready to be deployed to three different target environments: OKE, instance groups, and functions. As you see in step 1, the build output is stored in the container registry as an image. You can also store other artifacts in the artifact registry. In step 2, the image artifacts from the registry and the configuration files from the repositories are copied into the target runtime environment. From the step 3, you can notice once these artifacts and the configuration files are pushed to the target environments, they are easily deployed and are ready to operate. From step 4, what we can see is the logs from the build runs and the deployments are sent to the OCI logging service for audit and governance, and your team can receive notifications from the events of your DevOps pipelines through the notification service. These logs can be further used for observability and management purposes. Let's take a look at the release strategy. The deployment goes through these continuous delivery stages orchestrated by the OCI DevOps service. In this example, consider a build pipeline that executes successfully and generates artifacts for deployment. It is configured in a manner that it triggers the deployment pipeline. The deployment pipeline here depicts how we can deploy those artifacts onto the test environment to perform regression or security testing. If the test suite passes, then you can promote the artifacts to your staging environment. Here we can perform smoke and UAT tests. After staging, you can run a canary test. Send a small amount of production traffic to a new artifact and then monitor the metrics. Canary test is used as a litmus test by studying how it behaves for a small percentage of end users. This allows DevOps team to collect data to help them figure out if their code is behaving the way they want it to or not. Upon receiving user feedback, if everything looks good, you can go ahead with full release to the production. Using the OCI DevOps service, you can automate as much as you want to, with a deployment pipeline and automated builds run without intervention. The DevOps projects offer many options to customize your deployment pipeline. Let's look at how to manage the deployment pipeline. You can edit pipelines to add, modify, or delete stages. You can also configure parameters to override the default values. The deployment pipeline can be run manually or triggered by the build pipeline automatically. Once the deployment pipeline is run, we get the provision to monitor the progress of every stage. Rollback is one of the highlights of deployment pipeline, which in case of failures, rolls back the state of application to previous successful version deployed. Similar to how we create stages in build pipeline, we must also create stages in the deployment pipeline. What changes here are the options used to create them. Let's take a closer look at each of the options available. Let's understand some facts about working with deployment pipeline stages. You can add multiple stages to a deployment pipeline, where each stage represents an action. For example, applying a Kubernetes manifest to your OKE cluster. Stages can be added in sequence or in parallel. You can remove any stage from the pipeline if they are no longer required. Deployment pipelines offer many deployment strategies to meet your needs. You can perform rolling updates as well as deploy using blue, green, and canary release strategies. With the ability to roll back a deployment coupled with support for various release strategies, deployment pipeline provides the capability to minimize the failure effect due to a bad deployment. Note, OCI DevOps deployment pipelines can work across OCI regions. From a single deployment pipeline, deployments can be executed into multiple regions in parallel or sequentially. Displayed on the screen are the three categories that the user can choose from while creating deployment pipeline stages. The user can choose the deployment environment stage to choose the target environment where he wishes to deploy the software. Users can also select the control stage, which will help them manage the progress of their deployment pipeline stages. They can also select the integration stage, which will help them invoke a function to run some custom logics. In DevOps project, deployments can be rolled back manually or automatically. You must think of a rollback plan and configure it during the stage creation step. Configuring rollback minimizes downtime if a deployment fails. After a deployment is completed, you can roll back a failed stage in the deployment pipeline to the previous successful release versions. During automatic rollback, other in-progress stage continues running, but the new stage cannot run, and the deployment completes as failed. There can be several reasons for rollback. Some of them are bug fixes, failed deployments, encountered vulnerabilities, and so on. When creating a deployment pipeline for a cluster or an instance group, you can select either automatic rollback or manual rollback option from the Actions menu in the Oracle Cloud Console. If you wish to go for a manual rollback, you must identify the deployment that has failed and then select the deployment ID to roll back based on the deployment timestamp and then roll back. Remember, Rollback of a single stage in the pipeline is considered a new deployment, and a snapshot is provided only for that stage during the deployment. As you can see from the image over here, if you wish to go for manual rollback, you must choose No as an option for automatic rollbacks. When creating a deployment pipeline for a cluster or an instance group, you can select Automatic Rollback as an option. If the validation fails, the release is automatically rolled back, and if the stage fails, the last successful release version is deployed. During automatic rollback, other in-progress stage continues running, but new stages cannot run, and the deployment completes as failed. As you can see from the image over here, you must choose Yes as an option to enable automatic rollback to last successful versions. To wrap up our discussion, in this lesson we covered DevOps project and deployment pipeline features in detail. We addressed topics like various deployment environments. We also discussed different stage options along with rollback scenarios. Another thing I would like to mention here is using OCI DevOps is free. Running the deployment pipelines is not charged to you. Of course, the runtimes to which the applications are deployed need to be paid for, and the storage required for the artifact registry as well as the container registry is charged to your cloud account. I hope you had a great learning experience. Thanks for watching. Hello, I am Mahendra Mehra, and as part of this demo, we'll be looking at the deployment pipeline. This demo is divided into following tasks. At first, we'll be seeing how to create a deployment environment. Then we'll go on to create a deployment pipeline and add the deployment stages to deploy the artifacts that were generated from the build pipelines. Kindly note, as part of this demo, I've already created an OKE cluster where we'll be deploying all the artifacts. So let's get started. Before we can create a deployment pipeline, we need to create a target for the deployment, which is called an environment. The OCI DevOps service can currently deploy into the instance groups, into Oracle functions and Oracle Kubernetes engine. In this particular demo, I'll be showing you how to deploy to OKE, which is Oracle Kubernetes engine. So let's jump to our DevOps project by clicking on the hamburger menu, going to the developer services and clicking on the projects. Now I'll choose the project that we've been using. In the resources section on the left of the page, select environments. This will take us to the environment page. Here we need to create an environment by clicking on create environment. This opens up the create environment form. Now we get to choose from the three environments, that is Oracle Kubernetes engine, functions and instance group. As part of this demo, we will be seeing how to deploy to Oracle Kubernetes engine. So let me select Oracle Kubernetes engine. Let's fill up the required fields like name and description. Okay, so I have given my environment a name mm_OKE and the description is Kubernetes cluster. Click on next. On the environment details page, make sure that you select the region that you are working in and the compartment where all your DevOps resources are managed. From the cluster dropdown, select the OKE cluster that you had pre-created. In my case, I had created an OKE cluster and named it as OKE_mmlab, so I'm selecting the same. Let me quickly hop onto a new tab and show you the existing cluster that I have already created. I'm going to the developer service, going to the Kubernetes cluster. And as you can see, under the CTDoc compartment, I have an OKE cluster already created, which is named as OKE-mmlab. That's the same that is being seen under the cluster dropdown. And you can also see that the current cluster is a public cluster. Once you verify all the details, click on create environment. This brings you to the environment details page, and as you can see, our environment has been created and is set to active. Again, the environment has been given an OCID. You can always go back and edit the environment. You can also use the add tags button to add tags to the environment. So with this, we have created the environment for the deployment pipeline to deploy to. Now let's go back to the project's homepage by clicking on the breadcrumbs. Now let's start creating deployment pipelines. So on the left hand side of the page under the resources section, click on deployment pipelines. Click on create pipeline And in the create pipeline pop-up window, provide all the details like pipeline name, its description. Okay, so I've added the pipeline name as storefront deploy and given a suitable description. Next, we'll have to click on create pipeline. Okay, so this brings us to the editor dashboard where we can start adding stages to our deployment pipeline. Since we are deploying to an OKE environment, we will be adding two stages. The first stage will do an actual OKE deployment and also create an OKE service object that matches to the deployment. And the next stage will be applying the Kubernetes manifest to create the ingress rules, as the ingress rules will route traffic using the service object. So to add the first stage, click on the plus icon over here and click on add stage. Since we are deploying to the OKE cluster, click on apply manifest to your Kubernetes cluster and click on next. Fill up the details for the stage in the stage form. Okay, so I've entered the stage name and the description. Now let's select the environment where we wish to deploy these artifacts to. Remember, we created an environment few minutes back. So from the drop down, select that environment name. Now we'll have to select the artifact that we wish to deploy onto this cluster. So the artifacts that we are deploying first are the service and the deployment YAML files. Click on select artifact. This will take you to the artifact registry and will display all the Kubernetes manifests that are available. You need to choose the ones that you have to deploy. So at present we'll be deploying the deployment YAML file and the service YAML file. So I've selected both of them. Click on save changes. Notice that both the Kubernetes manifest files have their versions as storefront_version. This will be substituted with the value of the variable which will come from the build pipeline phase when we have it trigger the deployment pipelines. Leave the override Kubernetes namespace field blank and set the if validation fails automatically roll back to the last successful version as yes. So this is required when you want the rollback to happen automatically. Let's say you wish to go for a manual rollback, then in that case you have to select this option as no. At present we'll be using yes to automatically roll back in case of validation fails. Validate all the information once before you click on add button and click add. Okay, so our first stage under the deployment pipelines has been created. Now we will add the another stage for the ingress rules. So to add another stage to your deployment pipeline, click on the plus icon over here and click on add stage. As you can notice, both in the build and deployment pipelines, we had an option to create a parallel stage. You can choose to create a parallel stage if the two builds that you are running are independent of each other and you want them to proceed parallelly. You can choose this option if you are trying to deploy to two different environments at the same time. For now, we will be going ahead with add stage. Again, the stage that we need to select is apply manifest to your Kubernetes cluster since we are trying to apply the ingress rules, and click on next. Populate the details. Okay, I've given this stage a name storefront ingress deployment and given a suitable description. Let's select the environment which is mm_OKE and we'll go on to select the artifact by using the select artifact button. And you need to select the storefront ingress rule YAML Kubernetes manifest file. I'll select that and click on save changes. Now as you can see, the artifact that you selected is displayed in the list over here. Again, the version is storefront_version whose value will be passed from the build pipeline once it triggers the deployment pipeline. Leave the override Kubernetes namespace as blank and in the validation fails automatically roll back to the last successful version. Choose it as yes. Click on add to add this stage to your deployment pipeline. Okay, now as you can see, we have two stages listed under our storefront deploy pipeline. Now that we have our deployment pipeline ready to run, but there are a couple of parameters that we need, specifically Kubernetes_namespace and external_IP. These are the very specific parameters that are required for deployments into OKE. And these are not set in the build pipeline. We need to set them explicitly under the deployment pipeline. So first we need to gather information regarding the Kubernetes namespace and the external load balancer IP. To gather this information, let's jump into the Cloud Shell. This command over here will help us identify the Kubernetes namespace. So if I hit enter, as you can see, the namespace that we are working in is The next thing that we have to know is the external IP for our ingress load balancer. So using this command, we'll get to list all the load balancers under the ingress-nginx namespace. And as you can see, we have an ingress nginx controller of type load balancer whose external IP is 129.153.98.9. So with these two information, we can set our parameters. One is the namespace and one is the external IP. Let's jump back to the deployment pipeline editor and click on the parameters tab and start creating our parameters. Okay, so I have added the parameter for external IP and I'm going to click on the plus icon to add it. Now I'll create another parameter for the Kubernetes namespace. Okay, so I have added the parameter for Kubernetes namespace as well. Let's click on the plus icon to add this. Okay, so you must have noticed that the parameters tab is available for both build as well as deployment pipelines. So what happens if the same parameter is defined in both pipelines? If a parameter is defined in both the build and deploy pipeline it triggers, then the value from the build pipeline takes priority. With this, we have come to the end of this demo. I hope you enjoyed the demo. See you in the next one. Thanks for watching. Hello, I'm Mahendra Mehra and welcome to this demo on combining build and deploy pipelines and automated triggering. In this demo, we will combine the build and the deployment pipelines that we have defined to have a successful build pipeline automatically trigger a deployment pipeline, thus reflecting how the DevOps service can deliver a continuous integration and continuous deployment process. This demo is divided into following tasks. At first, we will add a deployment trigger to the build pipeline. Then we will be testing the integrated pipeline process. Towards the end of this demo, we will be creating a trigger which will invoke the build pipeline automatically. So let's get started. So if you recollect from the previous demo, we ended up creating two stages for our storefront deployment pipeline. A deployment pipeline can be run independently by clicking on the run pipeline. But for this demo, we won't be able to run this pipeline as we will have to add few more parameters like the storefront version which is coming in from the build pipeline as well as the OCIR host and other values. But just in case you are planning to create a deployment pipeline, you can independently run that pipeline by clicking on the run pipeline button over here. We will be running the deployment pipeline we just created using a different approach. For that, we will have to go to the build pipelines. So let me click on the My DevOps project in the breadcrumb and go to the project's homepage and select the build pipelines. Under the build pipeline, select the build storefront pipeline that we created in our previous demo. Alright, so this is the editor dashboard for our build pipelines. Now we can add a new stage to trigger the deployment pipeline from the build pipeline. So to add a stage, click on the plus icon at the bottom. Click on add stage. Now we'll be selecting from one of the optional stages that we have. We already demoed you how to deliver artifacts. This time we'll be doing the trigger deployment stage. So let's click the trigger deployment stage. Also note you can add a wait stage to your build pipeline. This basically pauses your build pipeline for the interval defined. For our demo, we will be selecting the trigger deployment stage and click on next. Fill the required fields like stage name and description. Okay, so I have filled up the required fields and I've given the stage name as start storefront deployment, given it a suitable description. Now you need to select which deployment pipeline you wish to trigger. So click on select deployment pipeline. And this will show you the deployment pipelines that you have created under the DevOps project. In our case, we have only one deployment pipeline that is created under this DevOps project. So we'll select our deployment pipeline and click on save. Once you click on save, the page displays all the deployment pipeline details that you have chosen. So we had declared parameters like Kubernetes namespace and external IP in our deployment pipeline parameters, which are getting displayed over here. Similarly, it is also showing you the artifacts that will be used in the deployment pipeline. So the artifacts that we had selected were storefront deployment YAML, the service YAML, and the ingress rule YAML. So once you validate all the deployment pipeline parameters and the artifacts that you wish to deploy, click on the add button. One thing to note here is that we have checked the send build pipelines parameter, and this is important because we want the parameters from the build pipelines to be passed into the deployment pipeline. Okay, so now as you can see, our build pipeline has been updated with one more stage, which is the start storefront deployment stage. Now let's run the build pipeline by clicking on the start manual run button. This will pop up a start manual run page. It has given the build run a name and it is asking you to validate your parameters. For me, the parameters are accurate, so I'll click on start manual run. The moment I click on start manual run, it brings me to the build run tab where I can see the build in more detail. Now as you can see, there are three stages that are defined in this build pipeline. The first stage is currently in action, so it's bordered as amber color. The other two stages are inactive, so they are bordered in gray color. And all the steps in each of these stages will be shown once they are executed. Currently, the first stage is under execution, and all the steps running in the first stage, as and when they progress, a tick mark is shown towards the right. This is the place where we get to see all the logs of all the actions that are taking place within the build pipeline. In the meanwhile, I'll open up another tab where I will take you to the deployment pipeline. So under the resources section, you can see that there is a deployment option available. Let's click on that. And you can see that there is no deployment currently found. But as soon as this build pipeline will finish uploading the artifacts to the container and artifact registry, it will trigger the deployment pipeline stage and we will see one deployment listed over here. So let's wait until the start storefront deployment stage gets triggered. The top space over here gives you an updated summary of what's happening in the build pipeline. As you can see, the status says it is in progress. The total duration specifies the time since the build is running, when was the build started, the number of stages that are completed out of 3 stages. At present it is 1 of 3, and how many stages are running. Since we have used sequential stages, it is running only one stage at a time. If you would have gone for parallel stages, you can have more than one number over here. You also get a stop run button just in case you wish to stop the build run. Let me also quickly read the logs for you. At present, we are in the second stage, which is uploading the artifacts to the container and artifact registry. And as you can see from the log output over here, it also reads the same. That is, it has started uploading the artifact storefront controller image to the container registry. And it is already done with the deployment YAML file and other YAML files for Kubernetes manifest. Great. As you can see, our second stage has completed successfully and it has turned green. Now it says that it has started triggering the deployment pipeline, and that also has turned green. So this does not mean that the deployment pipeline has completed its execution. It means that the deployment pipeline has been triggered successfully. Let's go to the other tab, and if I quickly refresh on this tab, superb. We can see that a new deployment has been triggered, which is in progress. So if I click on this deployment name, it brings us to this page where we can closely observe the deployment progress. If you remember, our deployment had 2 stages. One was to configure service and deployment on the Kubernetes cluster, and the other one was to configure ingress deployment. So currently the first stage is in progress. Okay, so the first stage has completed successfully. Now it's going to the second stage where it will be configuring the ingress. You can also read the log or download them for troubleshooting purpose. Alright, as we can see, our deployment pipeline has executed successfully. The status says it has succeeded. The total duration it took was 1 minute, and the number of stages that it completed is 2 out of 2. Now to confirm our new deployment, we can go to the Cloud Shell and check if the new pods were created or not. So let me quickly take you to the Cloud Shell. We can check using the kubectl get pods command. Notice that the storefront pod is very young, just created 5 minutes ago. We can also use the curl command to check the status of the service that is running. So if I hit enter, it says the version of the code is 1.0.0 as defined in the status resources.java file. Okay, so let's take a look at triggering the build automatically. So far we've been triggering the builds manually. That is okay in some situations, but in many cases you would want the process to happen automatically. That is, when a developer commits his code into the code repository, the build pipeline must automatically get triggered and the artifacts must be generated, which then later on should be deployed using the deployment pipeline onto the environments. It can be any OKE functions or instance groups. So let's go to the main page of our DevOps project by clicking on the breadcrumbs. Click the triggers menu under the resources section on the left side. Click on the create trigger button. Give this trigger a suitable name. Alright, so I have given this trigger a name called storefront trigger and gave it an appropriate description. Now click on the source connection and select the OCI code repository because this is where our project code resides and where our commits will happen. So once you select the OCI code repository, it is asking you for a few more details. It is asking you to select the code repository. So click on select and choose your project code repository, which is Cloud Native Storefront Helidon. I'll select that and click on save. Now it says to add an action. Click on add action and this particular pop-up asks you to select the build pipeline that you wish to trigger. So click on select. Since there is only one build pipeline, we will select the build storefront build pipeline and click on save. Now, since the event that we want to trigger the build pipeline is a push based event, since we'll be committing our code into the OCI code repository, let's enable the push based event. And when you enable the push based event, it is asking you for the source branch. That is, for which branch commit you would want this event to trigger a build pipeline. So let's select the source branch. Since the code that we are talking about is in MyLab branch, I'll be selecting the MyLab branch and click on save. Verify all the information that you have populated and click on create. Alright, this brings you to the storefront trigger page, which says the trigger is active and it gives you certain information about the trigger on this page. You can always edit the trigger that you created using the edit button, or if you wish to add tags, you can use the add tags button and delete the trigger if you no longer need it using the delete button. Okay, now that we have created the trigger, let's put it in action. Let's make a change in the code, specifically the status resources.java file, where we will change the version number from 1.0.0 to let's say 1.0.1. And once we commit this change into the code repository on the OCI, this change or this commit must trigger the build pipeline, which in return will trigger the deployment pipeline. And once we run the curl command to check the status of the storefront service, it should mention that the version that it is running is 1.0.1. Let me take you to the Cloud Shell and let me ensure that I have logged in into the local code repo. So I did an ls to quickly check if I am in the local code repo. Yes, I am. Now I will make the change in the status resource.java file and change the version number. This is the file that I will be editing using the nano editor. So let's hit enter. As you can see, this is the path that the curl URL hits, and I'll be changing the string version value from 1.0.0 to 1.0.1. Alright, so I have made this small change in my status resource.java file and I'll quickly save it. Let's commit these changes to the local git repository using the git commit command. Okay, so as the git commit says, one file has changed and there's one insertion and one deletion. Now let's push this change into the remote repository using the git push command. So the command is git push DevOps, which is the name of my remote repository, and the branch into which I am trying to push is the MyLab branch. Again, remember the trigger was created for the MyLab branch. So before I hit enter, let me take you to the OCI console and show you that there are no build pipelines or deployment pipelines currently running. So let us go to the project, and if we click on the build history, so these are the previous build runs that are already completed, and currently there are 3 in the list. So as we move ahead and push the changes to the MyLab branch, what we should see is a new build being triggered, which will ultimately trigger the deployment. So let's hit enter. Alright, so the commit has taken place and the MyLab branch on the remote repository has been updated. So let me go to the OCI console and let us check if a new build has been triggered. So let me quickly refresh this page. Awesome. As you can see, a new build pipeline has been triggered and it is in progress. So if you want to monitor it more closely, click on the name of the build run. As you can see, the build pipeline is in progress, and once it completes, it will go on to trigger the deployment pipeline. The deployment pipeline will fetch the new versions of the artifact that are stored in the artifact registry and the container registry and deploy them to the Kubernetes cluster. Alright, as you can see, the upload storefront artifacts, which represents the deliver artifact stage, has completed its execution. Let me quickly take you to the container and the artifact registry to show that the new artifacts were generated. So if I go to the artifact registry and click on the artifact repository, you can see that the new artifacts are generated with the new version 1.0.1. This is basically due to the change that we made in the version within the status resource.java file. So this represents that a code change will reflect changes into the manifest files, and the similar changes will be reflected into the container image. So if I take you to the container registry, you see over here we have a new container image with the version 1.0.1, which is having the new code stored in it. Now from the build pipeline, we can see that it has also triggered the deployment stage. So let's go to the deployment stage by clicking on the project from the breadcrumbs and going to the deployments. Yeah, so there's one deployment that is in progress. Let's click on that. So the first stage within the deployment pipeline is in progress. Alright, so as we can see, the deployment stage has completed successfully, where we were successful in deploying both the service, deployment and the ingress manifest files. So now to see whether the new deployments are reflecting the changes that we made in the code file, let's go to the console. So this curl command will query the status API endpoint of the storefront microservice, and it will return the version string. So this time the version string should return 1.0.1 as we made that change, which triggered the entire CI/CD pipeline. Great. So from the output, we can see that the CI/CD process worked successfully, and the code that was committed into the code repository was built by the build pipeline, and then the artifacts were stored in the respective registries, which were later pulled by the deployment pipeline to be deployed on the Kubernetes cluster, and which can be very well seen over here. Another thing that I would like to show is the manual rollback. So let's say one of your stages fails, you can always roll back to the previous deployment. For that, you have to click the 3-dot icon and click on the manual rollback. In this case, you have to select the deployment that you wish to roll back, and in this case, you'll have to select the previous successful deployment and then click on close. It then shows you the parameters that are part of the deployment and the artifacts that will be used to roll back to the previous stage. So as you can see, currently deployed version was 1.0.1. If I'm trying to roll back manually, it is asking me to roll back to version 1.0.0. The moment I click on rollback stage, it will roll back this particular deployment to the previous version. So that's it from the demo. I hope you liked the demo and found it useful. Thanks for watching.